Alright, so welcome to this real-time lab view video tutorial, part 3. The point of this video is to show you how to do your Simulink controller, which is the meat of everything. So I have a program that I already built, which is used for doing space vector modulation, and you don't really need to get into the details of this, but this is for space vector generation. This is used mostly for, inverters. If you want a three-phase reference with an amplitude of 170, I just have it like this so I can multiply the amplitude and change the amplitude of the sinusoids. So yeah, this block here is actually a conversion from my VA-ABC. I have 3 references in the ABC frame of reference, and I'm going to change them to alpha beta by this matrix multiplication, which is also known as Clark's transform. You can look that up. But again, this is not the important part of this video. Alright, so now we got this. Here I'm monitoring the phase A, which is equal to that U that I have here there in the input. I'm just outputting it so I can monitor it, and you can see this divider, which is divided by 100. The whole point is my device, the device that I'm using, physical device, cannot take more than 10 volts. So if I wanted to look at the voltage, just look at the frequency, I have to scale it down. So now I've scaled it down to 1.7 volts peak. And here I'm changing the value of the VDC, which I'm just using to normalize. This would be assuming I have an inverter whose DC link is 400 volts. And this green block here is where I'm actually doing the space vector modulation. And here I'm also monitoring these V alpha beta, which are also the inputs, and the VDC. And here I have these 3 blocks here are essentially outputting the 3 duty cycles that I would take out and take to my inverter. That would determine the switching times for the inverter. So yeah, we have all this, and then we have these yellow blocks here. And then if you want to know how to get these yellow blocks, these are yellow blocks that make everything possible. So we go to the Simulink library, and it should be under a folder called NISIT blocks. You can see all 3 of them. One of them is for inputs, the other one is for outputs, and the other one is this signal probe. So if you the first thing before this is you want to verify that you have everything working correctly. And the way to verify that is once you start MATLAB, you should get this message that says SIT added paths for SIT whatever version it is, and it should say starting the SIT server on whatever port it is. This actually means that MATLAB and SIT have synced successfully. So I mean, if you see this message, then you should be able to see those blocks in the library. So that means you have everything pretty much going. So going back again, so you'll be able to see all these 3. Here's the input. This is used for inputs. If you want to bring a signal in from outside and you want to link it or map it to this controller, and then you have outputs, like for example this VA here, this VA here that I want to output, and the 3 duty cycles, because this is the main point is to output these duty cycles. So I have this signal probe block, and it has this. The important thing is that this is the block that makes it all happen. You have to have this in your controller. It's like the power GUI block in sim power systems, and that has to be in your top level controller. That's the important thing. So after you have configured everything and you have your inputs and outputs, you're going to go to simulation and configuration parameters. The first thing is you're going to go to solver, and you have to make sure that your start time is at 0, your stop time is for infinity. You're going to use fixed step. And here's an interesting thing actually. When I run my system, I noticed that I had to put this value for the sampling time. It's 1.6777 e to the minus 11, which is an absurd number to have as a sample time. But what happens is I think there's a frequency scaling issue between LabVIEW and MATLAB, so I've actually had to put this number in there and this number corresponds to 10 kilohertz, to a frequency of 10 kilohertz, or it corresponds to a sample time of 1 over 10 kilohertz. So in order to run my my controller at 10 kilohertz, I've had to put this number there. So you can just get how much the scaling is by dividing this number by 1 over 10 kilohertz. And this is something that I found experimentally. I would change the frequency of my references and saw what in a scope what the actual references that I was bringing out were. So you're gonna go to System Target File, continuing on with the configuration, and you're gonna select NIDLL.TLC, and you can pretty much leave everything the same, and you're gonna go ahead and hit Build. Build. This is the important part. This is what's gonna generate the. You get a message here. This is what's gonna actually generate that DLL file, and the DLL file, what it does is it contains the information on your model. So you're generating a file that contains all the information that you need, and you can call this file from LabVIEW. And then map inputs and outputs to it. So that's pretty much it. And then once it finishes the build, which may take longer than in the video, just fast forward it. You should see this, that SIT, successful completion of real-time LabVIEW, so on and so forth, and you should see your actual model name in there. So after you're done with this, you can go ahead and close everything. And like I said, we want to be able to map these outputs, so all this information is contained in that DLL file. That's why we have these yellow blocks here, because we're gonna be able to map that with LabVIEW. You're gonna see that later on. So you're gonna save everything and go on to the next step. So next step is you can actually go to the folder. Wait, this is not it. Let me go back. This is the actual folder where you saved your model, your Simulink model. You can see it here. After you generate the DLL file, there will be a folder with the same model name on it. So you're going to double click on that, and here it is, the DLL file that has been generated containing the information on that model. And you can see all these other configuration files, but they're not that important right now. They're just configuration files that will come into play when you're actually using SIT. So you're pretty much done with this step. The important part of this was just generating that DLL file, and now you can move on to the next step, which is generating your VI in LabVIEW, and then being able to map things and being able to put everything together. So alright, that's it for this part. See you in the next part.